Static.
Okay, today we're going to solve a question called find players with 0 or 1 losses. This is a question I randomly picked, and I'm going to solve it today. Okay, cool. So we're given an integer array called matches, which is a list of lists where the first is the winner and the second is the loser. So 1 is the winner, 3 is the loser. And in the output, we want a list of size 2, so 2 sublists, where the first sublist has all the winners. It first has all the players that have not lost any matches. So not lost any matches means that we don't have any L's in that sublist. We can just think of it that way because each player is represented by a number. So player 3, player 6, player 5, player 7, player 8, player 10, player 9. And list 1, which is going to be the second output, is going to be a list of players that lock exactly 1 match. So we can do this multiple ways, but the easiest way is just to say that there's 1 L in 1's value list or 2's value list because the player is going to be the key of the dictionary, if that makes sense. And then we're going to return it in sorted order at the end, which is really important because, right, these have to be in order. So as you can see here, it looks like no players have lost any matches, no players have lost exactly 1 match, So then we're still going to have 2 sublists in the output. And the second one's going to be empty. Okay, cool. So first thought is to iterate through the sublist. So for I and range length matches, and then put it in a dictionary. It's called myDict equals to, we can use a default dict in Python, so we don't have to check, if this element is not already in the dictionary, then set it to 0 and then plus equal to 1. We can just directly do this. So basically, so if matches I 0, so we want the list of players that have not lost any matches. So we know that the left is going to be the winner. So we can say myDict matches I1, which is going to be the winner, dot append W. And then we can count. So we know this is one time. And then we also have to do the loser, which is matches I0 dot append L. Because each sublist has a winner and a loser. If one guy wins, the other guy has to lose, etc. Okay, so cool. So let's print the dictionary so we can make sure that we're doing this correctly. We want the players as the key, and then how many matches. I like to print things a lot so I can understand where I'm going. Okay, cool. So we have a 3. Let's see, player 3 has won twice and lost once. Player 1 has only lost once. Player 2 has lost once. So you know that 1 and 2 are going to go in the left-hand side of the output list. So now what do? We iterate over our dictionary. So for key in myDict, let's say if myDict key dot count of W, we not lost any matches. Okay, let's take care of that first. So if not lost any matches, that means there's no L. So if L is not in the value side of the list, myDict K, then we can, we have to have 2. So we say like, not lost any. So you can say winners, losers equals to this. That's 2 empty lists. So if it's not inside of this, then we have not lost any matches. So we can say that this is a winner. So we can say winners dot append K, because myDict K is the value and K is the actual player itself. But myDict K is the frequency while K is the actual player. And then we can say, okay, so if players have lost exactly 1 match, so if myDict K dot count of L, so that means L appears exactly once on the right-hand side of the dictionary, is equal to 1, then we can say losers.append k. And let's just print, well, we need a result at the end. Result.append winners. We're going to join these together at the end, winners, losers. And then we can return result. That should be it. Except we have an issue because, again, we have to sort these and this is not correct. So 1 second. So we print our dictionary and then have not lost any matches. Okay, lost exactly one match. Okay. Is not in NYDK. Yep, we have not lost any matches. So pen this, pen that. Let's print our 2 lists first to get a better idea of how to do this. So C6789312, that's not correct. So let's see what's going on here. Okay. So the winner, 1 is the winner here. So why are we having L here? Maybe I did something wrong. So if 1 is here, append W. Right, winner, loser. Winner, loser. Got this backwards, see? The left-hand side is the winner, not the right-hand side. Let's run this again. Cool, so now we got the answer, except it's in wrong order. So what do? We got to sort them. So now, for each sublist in result, r.sort, and then we can return the result. Okay, so that should be fine. There you go.
Okay, sound good?
So the time complexity of this is we have 3 loops here. So input, so O of n plus O of k for the size of the dictionary, and then plus O of r. So probably O of n plus k plus r. So still linear, but obviously that's not ideal because not only this, but we're taking up more memory too because we need a dictionary. And then we have to sort them many times. So I'm pretty sure this is an O of n squared solution. It's like more of a brute force solution. It's not the most efficient, but you know,
I think
I'm sure we could optimize this as length, but yep.
Right, you know it's not efficient, but you complete it. I think it's good.
Yeah.